Hello everyone. Sorry I haven't been able to update my channel for a week, but I'll promise to upload videos every weekend. This would be our third video of the Algebra 2 and Precalculus series. So let's get right in. Linear equations. So an equation shows two equivalent expressions, and equivalent expressions are expressions that have the same value. So 2 and 3 minus 1 have the same value. The solution or root is a number that satisfies the equation. So if we had an equation 2 equals 3 minus 1, then it'll be satisfied for any number. As you can see on the board over here, 2 is equal to 3 minus 1 has no variables, so all numbers would satisfy this equation. But if we had something like x is equal to 3 minus 1, then the only number that satisfies this equation is x is equal to 2. This is the solution or the root of the equation. Equivalent equations have the same solutions. So x is equal to 2 and x is equal to 3 minus 1 are equivalent equations. They both have the solution x is equal to 2. So some properties of equality that are useful to solve equations. If a is equal to b, then a plus c is equal to b plus c. So for example, if I have x plus 3 is equal to 5, let's say I'm given this, how do I solve this? Well, we can use the addition property of equality. If we add negative 3 to both sides. So if we add negative 3 to this, we get x plus 3 plus negative 3, or just minus 3, is equal to 5 plus negative 3 or minus 3. So this would be, these cancel out, you get x is equal to 2. This would be how you solve an equation like this. And a similar property is the multiplication property of equality. If a is equal to b, then a times c is equal to b times c. Notice that we have it and c is not equal to 0. This only matters if we're trying to find the solution of an equation. So for example, if we have 1/2 x is equal to 4, then you can multiply both sides by 2. And you get x is equal to 8. And this would be the solution of this. Now, the reason we don't have c is equal to 0, c is not equal to 0, is because if we multiply both sides of this by 0, we get 0 is equal to 0. This is still true, but this doesn't have the same solution set. This solution is x equal to 8. This solution is all real numbers. So linear equation is an equation that has ax plus b. So it has one variable raised to the first power. And you may also see something like ax is equal to b, but that's just similar to this. It's actually easier because to solve an equation, you have to first isolate the variable. So in this case, we'll turn this into ax is equal to negative b. In the other form, ax is equal to b, the variables are already isolated. So let's take a look at the more challenging one. To be honest, this is more like a review from Algebra 1, so it's not that challenging all by itself. So we have ax is equal to negative b. Now, how do we solve this? Well, first thing, to get this, we had to use the addition property of equality. We add negative b to both sides. But now we have to get x alone. That's fully isolating the variable. This, you're isolating all the terms for the variables. Ax is still a term that has the variable, and it's the only term that has the variable. Over here, you want to multiply both sides by 1 over a. And if you do this, let me actually get this out of the way. if you multiply both sides by 1 over a, you get x is equal to negative b over a. And if you ever come across an equation like this is the solution. If you want to write this down, you can, or you can just go through the steps and solve it. And there are different types of linear equations. An identity is the solution set is all real numbers. For example, 2 is equal to 3 minus 1, our example from the beginning. In this, all real numbers make it true. And it's called an identity because we know it's true. When we get into trigonometry, you'll see that there are some trigonometric identities that are true for all variables. Or even some algebraic identities that we will see soon. A conditional equation is solution set is finite, but not an empty set. So for example, x is equal to 3 minus 1. Our next example. And this, the only set is, the solution set is x is equal to 2. That's why it's conditional. It's a finite, but there's still a solution. And then a contradiction is solution set is an empty set. And you've probably heard the word contradiction before. It's basically saying like, it's wrong. It's not what we know. So for example, if we say 2 is equal to 3 plus 1, that'll be 2 is equal to 4. And that's not wrong. Sorry, that's not right. It's never right. That's why it's called a contradiction. Another type of linear equation that you might see is ax plus b is equal to cx plus d. This is also important because you need to know how to isolate the variables. Here, now you have to subtract cx. So you get ax minus cx while subtracting b is equal to d minus b. And then you use the anti-distributive property, a minus c times x is equal to d minus b. And then with this, you get x is equal to d minus b over a minus c. And you can write this down if you want, or you can go through the steps. Either way, you have to know to isolate the variable. A literal equation is an equation that involves multiple variables, and it's also called a formula. For example, the volume is equal to base times height. And it involves 3 variables. What you can do with a literal equation is you can solve for a specific variable. So right now, v is the specific variable that's being solved for. You can also solve for, say, base. You can write base is equal to, but how do you isolate base? You have to divide both sides by h, v over h. Or you can also write h is equal to v over b. If you go through the steps, you'll notice that you just have to divide b from both sides. Applications of linear equations. So linear equations are probably the easiest type of equation you'll see. Some applications though, the main thing is to know when to use what. So to solve an applied problem, first you read the problem carefully, you assign variables, you write an equation, you solve the equation, and you check your answer. So as you'll see in the examples that I'll show you this lesson, each of these steps is important. First, you read the problem, see what they're asking. Then you assign the variables given what's known and what is needed. Then you write an equation using the variable and what's known. You solve the equation and you check your answer. So a geometry problem uses diagrams and geometry formulas. So for example, let's say we're given a rectangular sheet of paper that has twice the length as the width. And the perimeter is 24 centimeters. So we know that length is equal to 2 times width. This is the mathematical way of writing it. If I had more time and if we were actually like on a whiteboard that I can write everything down, I would say the length is twice the width. But right now, let's say I'll skip a step and say L is equal to 2W. These are basically assigning the variables. And we also know that P is equal to 24 centimeters. Important thing, remember centimeters because units are always needed in math problems. So first thing to know, this is length, this is width. So we can label it width, length. But now we have two variables, so this isn't linear. We could do something, and instead of writing length, we can write 2W. Why can we do this? Substitution. We know that length is equal to 2W, so we can just substitute length for 2W. So now we have this. Width is W, length is 2W. Now we also know something from geometry. Perimeter is equal to width, length plus width plus length plus width. It's the sum of all the sides. And which means perimeter is equal to 2W, which is length, plus W, plus 2W, which is length, plus W. And this means that P is equal to 6W. Now we also know the perimeter is 24 centimeters. So we can substitute that in here. 24 centimeters is equal to 6W. W is equal to 4 centimeters. Let's say the question asks for what is the area of the rectangle. So now we know the width is 4 centimeters. That's not our final answer though, because it's not asking for the width, it's asking for the area. So with the width, you can find that the length is equal to 8 centimeters. It's twice the width, which means the area, as we learned in geometry, is length times width, which is 8 times 4, 32 square centimeters or centimeters squared. And that would be our final answer. First, we read the problem carefully. I mean, there's no problem here, but like if it was on a test, then you would read the problem. You might want to underline what's known and what's unknown. We assigned the variables, length, width, and perimeter. We wrote an equation. Well, all of this was basically writing an equation. We solved the equation. We got W is equal to 4. And most important step, we checked the answer. We checked, is 4 what they want? Is the width what they want? But that was not the case. They asked for the area. So that's why the most important step is to check an answer. Most people get a problem wrong because they put the wrong answer. They might say 4 centimeters instead of 32 square centimeters in this problem. Another important type of linear equation is motion, and this uses D is equal to RT, where D is the distance, R is the speed or the rate, which is why it's R, and T is the time. So easy problem, or relatively easy to be honest. A car is driving at a speed of 80 miles per hour. It wants to go from Concord to Sacramento. I don't know the actual distance, but let's just say it's 180 miles. There, not too easy. So how long would it take to get there? So we use the formula D is equal to RT. First thing, we read it carefully. Second thing, we need to assign variables. So we know the rate, we know the distance. What we need to know is the time. So we write T is the time. We write an equation. So distance 180 is equal to rate 80 times time, T. Note that the time is in hours because this is in miles per hours. So the time has to be in hours. Now we solve the equation. T is equal to, divide both sides by 80, 180 over 80, which is equal to 9 over 4, or approximately 2.25 hours. There. That's a relatively easy problem. There are harder motion problems as well. Mixture problems, V is volume, R is rate, and Q is quantity. And this usually involves making a table. So let's say we want a mixture of yellow and red paint, or how about some 30% acid, and we're given 30% acid and some water, and we want a 20% acid. So let me quickly draw the table so it's easier to understand. We have volume is equal to rate times quantity. So these are volume, these are rate, these are quantity. These are 30% acid, these are water, and these are result. So the rate of this is obviously 0.3 or 30%. It's easier to write as a decimal because we're going to have to multiply. Let's say we're given 4 liters of this, which means V is equal to R times Q. So this would be 1.2. Next, water. Water has 0% acid in it. So since it's 30% acid, we're talking about how much acid it has. Quantity is X. It's asking how much water would we need to create a 20% acid solution. So that's our rate of the total. Volume of this would be 0. Notice that our quantity and volume are different. So quantity is the total amount, and volume is how much acid we have in that. So if we mix these together, what do we get? Well, we have to add these two up to get this because we're mixing them together. So our total amount of acid we would have is 1.2. 1.2 from the 30% acid and 0 from the water. But how much quantity would we have? 4? No, because we also have the X liters of water plus the 4 liters of acid. So it should be 4 plus X. So now what we want to do is find X, right? So we have this equation, 1.2 is equal to 0.2 times 4 plus X. 1.2 is equal to, if you distribute, you get 0.8 plus 0.2x. I really don't like decimals, so we can multiply everything by 10. And if we multiply 10 to this side, we get 12 is equal to 8 plus 2x. 2x is equal to, subtract 8 from both sides, you get 4. So x is equal to 2. We solved the equation, now we have to check our answer. Are they asking for X? Well, in this case, yes, because they're asking how much water you would need to add. So that's the quantity of water, X. So the correct answer would be 2 liters. You might be wondering why we had to do all this. Why couldn't we have just used this? This had the equation 0 is equal to 0x, because we already had 2 knowns and 1 unknown in a row. Well, like I mentioned with the multiplication property, if you multiply by 0, you're just going to get 0 is equal to 0, and that's identity. It's always true. So we can't really solve for X in this case. If you want, you can pause. If you want, you can pause the video and write this down, but I'll move on to the next type. So yes, like I said, the concentration of the final mixture must be between the concentration of the components. So in the previous example, we had 30%. That was our starting. Another component was 0%, and our final was 20%. So that fits. Next is interest, or we'll be talking about simple interest right now. But there's also compound interest, which we'll talk about when we talk about exponential functions. So simple interest also requires a table of sorts. And this uses the formula I is equal to P times R times T. So, for example, let's say I have $5,000 and I want to put some in 8% interest and some in a 6% interest. Now, I know it's obvious that you should put all in the 8% interest to get the most amount, but this is a math problem and we don't deal with common sense. Note that in real life, you won't get high percentages like 8 and 6%. You'll probably get something like 0.5% or 0.25%. And these are even generous. Now, these are the two rates that we have. And if we put, if we get a total of $200 of interest, how much did we put in each one after 1 year? So our time is 1 because time is measured in years. So all we don't know is the interest and the principal. If we know one, then we know the other. So since we don't know principal, we can put x. Would this be y? Do we need two variables? And the thing is we don't, because we know we start with 5,000 and principal is basically the initial amount for each. So if we put x in here, we have to put 5,000 minus x here. Sorry, let me write that better. We have to put this much over here because we're dividing them between these. Now we can solve for I, and this would be 0.08x because you multiply all of them together. This one would require a bit more work because there's a 5,000 in it. So 0.06 times 5,000 would be 300 minus 0.06x. Now, we want to add these up to find the total interest, right? So we get 0.08x plus 300 minus 0.06x is equal to 200. Some of you might notice something a bit off about this, but let me explain it to the others. So we have 300, and if we combine the like terms, we get plus 0.02x is equal to 200, which means 0.02x is equal to negative 100, because we have to subtract 100 from both sides, which means x is equal to negative 20,000. Right, we put negative 20,000 in this interest. What did we do wrong? Well, technically we didn't do anything wrong because we started off with a total of $200. So this is a contradiction. It's an example of contradiction. But if we had something like 300 and, oh, I don't know, $50, then we can solve this. Let me just erase this. Now we have 350 as a total. So 350, And if we subtract 300, we get 0.02x is equal to $50. And therefore, 2x is equal to $5,000. And sorry, I don't have space. So x is equal to $2,500. So basically, we're dividing them equally. Now, this works, but the previous one was a contradiction. It's an example of a contradiction. Now, over here, we have $2,500 here and $2,500 here. So that's our answer to the question. A mathematical model is an equation that describes a relationship. And you can see it with population. So a linear model uses a linear equation. And for example, if we're given, why do I keep on? Let's say there was 50 zebras, and then there were 100, and then 150, 200, and so on and so forth. If we plot them, as you'll see in our graphs and functions lesson, we get a graph like this. This is a linear model. It's increasing by 50 each time. Now, moving on to complex numbers. Complex numbers don't have to do with equations exactly, but they're a necessity for quadratic equations, which is the type of equations we'll discuss next. Now, an imaginary number is I. I is equal to square root of -1. That's the definition of an imaginary number. For a long time, people thought that you can't take a square root of a negative number. I mean, I even told you that in our review units. But if someone did take the square root of a negative number, you would get I. It opened up a huge field of mathematics called complex numbers. Some properties. The square root of -a is equal to I root a. So for example, square root of -2 is equal to I root 2. Square root of -4 is equal to I root 4, but root 4 is basically 2, so this is equal to 2i. The powers of I repeat in a pattern. So I to the power of 1 is equal to I squared is equal to -1, because the square root of -1 squared is just equal to -1. Now I cubed, how would you do that? Well, we know I cubed is equal to I squared times I to the power of 1. By the power of exponents, you add these up to get I cubed. I squared is -1. I to the power of 1 is I, so you get -I. And then I to the power of 4 is equal to 1, because this is basically I2 squared, sorry, I squared to the power of 2, which is equal to -1 to the power of 2, which is equal to 1. And then I to the power of 5 is equal to I to the power of 4 times I to the power of 1, which is equal to 1 times I, which is equal to I. And it repeats back. So for example, I to the power of 1978, well, 1978 is equal, is divisible by 2, but it's not divisible by 4. And which means it's not equal to 1, but it is even, so it must be divisible by 2. So 1980 is divisible by 4, so this would be 1. Instead, we have to divide this by I squared to get this. I squared is equal to -1. So I to the power of 190 divided by I squared is equal to I to the power of 1978, which is equal to 1 divided by -1, which is -1. Or you can just see what its remainder when you divide it by 4, and since it has a remainder 2, it'll fall under the category of I squared. A complex number is basically a plus bi. So 2 plus 3i, for example, is a complex number. A and b have to be real numbers because it can't be something like I plus 2i or 2 plus I. If a plus bi is equal to c plus di, where a, b, c, and d are real numbers, then a is equal to c and b is equal to d. This would be helpful when proving a formula that we'll soon see has to do with division. To add and subtract complex numbers, you add and subtract their corresponding parts. So an important thing to note, if this is a complex number, this is called the real part, and this is called the imaginary part. So in 2 plus 3i, like mentioned before, the real part is 2, and the imaginary part is 3i. Oh, oops. That should have been a 2. So if we were to add 2 plus 3i and 4 plus, well, actually, we'll do 4 minus 2i. If we were to add these up, we add the real numbers first, which is 6. And then we add the imaginary numbers. 3i minus 2i is equal to I. So this would be our answer. To multiply them, there's this formula if you want to write it down, or you can just multiply them. So 2 plus 3i times 4 minus 2i, was it? Yeah. You multiply their reals. We use the FOIL method. So first, 8, outer minus 4i, inner plus 12i. Now we come to the fun part. Last, 3i times negative 2i minus 6i squared. Now I squared is negative 1. So this, instead of being minus 6i squared, it'll just be minus negative 6 or plus 6. And if you combine like terms, you get 14 plus 8i, and that would be your final answer. Conjugate, if you remember from radicals, a conjugate of a radical, root a plus root b, is root a minus root b. And this is similar for imaginary numbers. It's an expression that cancels out the imaginary numbers. So in this case, if it's a plus bi, it'll be a minus bi. And that's the same reason. When you multiply these out together, you get a squared plus abi, these two, minus abi, plus abi minus abi. And then here you get minus b squared I squared. And that's just basically plus b squared. And since these cancel off, you're left with a squared plus b squared. No imaginary number whatsoever. So right, like I said, they're the difference of squares, and their product is a squared plus b squared. So now division. The main thing about division is you cancel off imaginary numbers in the denominator. So for example, if we had 2 plus 3i over 4 minus 2i, you have to find the conjugate. 4 plus 2i, and like with radicals, you divide top and bottom over here. And now if you multiply this out in the denominator, you get 16 plus b squared over here is 4. And on the numerator, when you multiply them out, you get 8 plus 12i plus 4i, so plus 16i, minus 6. And after a while, you get used to it and you don't have to write out the I squared and simplify it. But if you simplify this, you get 1 plus 8i over 10. And important thing to know with imaginary numbers, this isn't right. What you have to do is write them separately. So you write 1 over 10 plus 8 over 10i, or 4 over 5i. It's a rule, you just have to follow it. You can't merge the real and the imaginary part together. You have to write them as separate fractions. And I told you we'd use this later, but it's a bit more advanced and we might get to it by the end of the series, but if not, it just square roots of complex numbers. If you feel you're ready for the challenge, you can search it up online. The proof is really interesting and it uses this. It's a nice application of complex numbers. If you want, you can search it up. Now, quadratic equations. So quadratic equation or second degree equation is ax squared plus bx plus c. Notice that a linear was ax plus b is equal to 0. This is ax squared plus bx plus c is equal to 0. These both are polynomials, by the way. That's an important thing about these equations. The zero product property, that's an important way to solve a quadratic equation, but it's if you have something like this. This is called the factored form of a quadratic equation. And it's when you have the factors of them. Factors we'll talk about more in the polynomial unit, but it basically has the x minus one of the roots, and then the x minus another one of the roots. So now we have the zero product property. We know this has to be a root because if this is a root, then you plug it in, you get 0 over here. Or this has to be a root. If you plug it in here, you get 0. And either way, 0 times another number is always 0 from the zero product property. This is the factored form of quadratic equation. It's a bit more rare because it's pretty easy to solve. Square root property, another rare property. You might not have to use this because it's just this. If you're given this equation, then x is equal to root k or negative root k. And that's pretty obvious. But if you had something like x squared minus k is equal to 0, you just have to take this to the other side and then apply the square root property. If k is less than 0, then x is imaginary, which is why we talk about complex numbers. Some of the quadratic equations have imaginary solutions. If k is equal to 0, this is called a double root because x is equal to 0 and x is equal to 0. How is that possible? Well, we said x is equal to plus or minus root k. And if k is 0, then x is equal to 0 or x is equal to negative 0, which is basically 0. And this is called a double root because it occurs twice, but it's the same root. Completing the square, you simplify ax squared plus bx plus c to use the square root property. So in this case, how do you complete the square? Well, I'll just show you on the board. First, you take the c to the other side. So we have ax squared plus bx is equal to negative c. You want to form a perfect square. So you can take out the a plus b over ax, which is equal to c. Divide both sides, negative c. Divide both sides by a, x squared plus b over ax is equal to negative c over a. Now, how do we form a perfect square? Well, we know a perfect square has to be in the form a plus b the whole squared. sorry, a plus b the whole squared, which is equal to a squared plus b squared plus 2ab. So we have a squared, b squared should be a constant. So then a is equal to x in this case. And if a is equal to x, then it'll be 2xb. And we already have this, right? So we want to find out what b in this case is. We have x. So that means that b over a divided by 2 is what we want. Because we can just cancel out the x's. Then you have to divide by 2 to get this is equal to b over 2a. So let me erase a bit so that I have more space. So now we have that it'll be x squared plus 2 times b over 2a times x plus b over 2a squared. Well, that's the left side. The right side, we also already got negative c over a. So this would be our left side. And if we have to add b over 2a the whole squared, or we can just rewrite this as b squared over 4a squared. Well, we have to add it to this side too. So now we have x. Well, we can actually simplify the left side. Since we know it's a perfect square, x plus b over 2a, the whole squared. And you have to add b squared over 4a squared here too. B squared over 4a squared minus c over a. And you can write this with the same denominator, which is 4a squared. We can write b squared minus 4ac over 4a squared. Now I'm going to erase everything else to get more space. And I'll continue on this side. So now we can use the square root property. X plus b over 2a is equal to, you take the square root of this. So square root of b squared minus 4ac over 2a. This may look a bit familiar to some people, and here's why. First of all, we need the plus or minus. That will make it pretty familiar. And then we subtract this value from both sides. We get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And we can rewrite this as, x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. This is how you use the square root property for a quadratic equation. So you just follow the steps that I showed you, and it'll be a bit more easier with numbers rather than variables. Instead of a, b, and c, you have like 1, 4, and 5, for example. But this brings us to our next topic, the quadratic formula. And this is what you just saw over here. This is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And just memorize this formula. And once you see a quadratic equation, you can just plug in this. In my opinion, the quadratic formula is the best method. Once you memorize it, it's easy to just plug it in. Anyway, The discriminant of a quadratic equation is the quantity under the square root. So let me bring back this and actually erase everything else because all we need is the quadratic formula for now. So the quantity under the square root is b squared minus 4ac. This part right here. Yeah, d is equal to b squared minus 4ac. And if d is greater than 0, then it has two real roots. If d is equal to 0, then there is a double root. And if d is less than 0, it's a complex root. So an easy way to solve them, first calculate the discriminant and see how many roots they have. If there's no real roots, don't waste your time. If there is two real roots, then you would either use the quadratic formula or one of the other methods. An application of quadratic equations is geometry, and important one, Pythagorean theorem. So in a right triangle, a squared plus b squared is equal to c squared. That's the Pythagorean theorem. Oh. So if this is the right triangle, as you learn in geometry, a, b, and c, the relationship between the side lengths a squared plus b squared is equal to c squared. So if we had a problem like a farmer has a piece of land in the shape of a right triangle. On one side, one of the legs, it's 10 meters. On another leg, and the hypotenuse is equal to twice the other leg. So we identify the variable x. This is 2x. We write down an equation. 100 is equal to, 100 plus x squared is equal to, now this isn't 2x squared because we're squaring the entire thing, not just x. This will actually be 4x squared. 2x, the whole squared, is equal to 4x squared. So now we can solve this. 3x squared is equal to 100. X squared is equal to 100 over 3, which means x is equal to 10 over root 3. Or if you want to simplify this, x is equal to 10 root 3 over 3. You can multiply by root 3 to both sides and you'll get x equal to 10 root 3 over 3. Now you may be asking, why aren't we using plus or minus? I mean, this is the square root property. Well, the reason we're not using plus or minus is because a length of a side can never be negative. Not in the real world. So if on most word problems, you won't have to use plus or minus. A quadratic model uses a quadratic equation to describe a relationship. So it's sort of like a linear model, except it uses a quadratic equation instead. Some other types of equations, a rational equation has one or more rational expressions. So for example, 2 over x plus 2 plus 3 is equal to 0. That's a rational equation. And values that make any denominator 0 are excluded. So it's important to note that if we write this equation, we have to specify x is not equal to -2. Because if x was equal to -2, then this denominator would be 0 and it wouldn't exist. An important application is work rate problems. So I'll give you a quick example. Rate times time. Some people write work done, some people write amount done, but either way, you make a table like this, and let's say you have two people, Bob and Charlie. So Bob can complete the house in 2 days. or let's just make it easier and say 6 hours, because days is pretty hard unit of time to work with. Charlie can complete in 10 hours. So he can complete one house in 6 hours, which means his rate is 1/6. Do you see how we got there? Because we're given 1 is equal to 6 times r. So in this case, r is equal to 1/6. Charlie can complete one house in 10 hours. So his rate is 1/10. So now what's the problem here? Well, most problems say, given this, how many hours will it take for them to work together? Now this is really simple because you don't really have to define a variable unless you really want to. So let's say it's X hours that they take to complete one house. Then you say that their rate together, I'm just gonna write total, rate total is equal to 1/x using the same logic above. And together their total rate, you add up these values. So 1/x is equal to 1/10 plus 1/6. And if you simplify this, you'll get 6 plus 10/60. And simplify it even further, you'll get 4/15. And that's not what they're looking for though, because that's the rate of which they work. They're asking for how much time. So 1/x is equal to 4/15. You can take the reciprocal. You can do a bit of algebra and you'll find out that x is equal to 15/4, or it's also written as 3.75 hours. So that's how much time they'll take working together. Notice that it's not just 8 hours because you take the average of their times. You actually have to solve and calculate this. A radical equation has one or more radical expressions. So for example, root x minus 2 plus 3 is equal to 0. Power property, given p is equal to q, then p to the power of n is equal to q to the power of n. And this is really useful in solving radical equations. So let me just solve this one really quickly for you. How would we do this? Well, root x minus 2 is equal to -3. Of course, this doesn't have any solutions because the square root can't be negative. But instead, if we had is equal to 3, so for example, instead of +3, we're -3. So root x plus 2 is equal to 3. How would we solve this? Well, we take both sides to the second power. And using the power property, we can have x minus 2 is equal to 3 squared, or 9. So x is equal to 11. And that would be our solution to this equation. Like I said, isolate the radical and raise to the power. And the power is usually the same as the index, unless you want to complicate things or if there are more than one radicals. If there's more than one radical, you repeat if necessary. So if we had something like this, first you take the square and you'll get x minus 2 plus x minus 3, because that's this squared plus this squared, plus 2 root, and then you multiply these. You get x squared minus 5x plus 6. That's in the radical, and this is equal to 100. But we still have a radical, so how do we solve it? We take these two to that side, and then we repeat by squaring it. And you should get a quadratic equation that should be easy to solve. It's important to check the solutions you plug into the original equation, because there are some values called extraneous solutions that work for the final equation, but they don't work for the actual equation. So for example, if we square both sides, we're basically expanding the domain. Previously, it couldn't be negative, but now it can be negative. If you have rational exponents, you raise to the power that's the reciprocal of the original power. So for example, if you had x minus 2 to the power of 3/2 instead of just 1/2, you would raise this to the power of 2/3 to cancel out the power. An equation quadratic in form is not a direct quadratic equation, but it can be simplified as one. And you use substitution for it. So for example, if we had something like 4x to the power of 4 minus 8x squared plus 16 is equal to 0. Well, we have a 4th degree polynomial, so this isn't quadratic. But if we say u is equal to x squared, then we have 4, and then x to the power of 4 is equal to u squared minus 8 times u plus 16 is equal to 0. So this would be our equation. And then you would solve this and then substitute back for x squared to get what x is. So inequalities, we talked about a bit about inequalities in the review videos. But now we'll talk about some properties and how to solve them. So here's just a disclaimer. When we say like given a property and we say is greater than, it can also be substituted for any of the other inequality signs as well. We just write 1 because it's too much work to write all 4. So like I said, we'll talk about some properties. If A is greater than B, then A plus C is greater than B plus C. So it's basically the addition property. And remember, we can use any of the other signs for this as well. And this is a key difference between equations and inequalities. It matters the sign of C when we multiply. If C is positive, then we keep the sign, but if C is negative, we change the sign. So if it was like 2 is greater than 1, and we multiply both sides by -3, then it'll be -6 is less than -3. You change the sign. A linear inequality is sort of like a linear equation, but it's ax plus b is greater than 0, not ax plus b is equal to 0. So you solve it like an equation by isolating the variable, and then you get a solution set that's usually not finite. I say usually because there are some exceptions. So an example of this would be 2x plus 3 is greater than 0, 2x is greater than -3, x is greater than -3/2, and this is our solution set. But there's another way we can write this. Interval notation. You can use it to write intervals as solution set. So an open interval is written like this. So for example, we said that it was greater than -3/2. And since it's open, it's a non-strict inequality, it's between -3/2 and infinity. And infinity is always written with an open interval. And the other type is a closed interval. So if it were x is greater than or equal to -3/2, then we would write it with a square bracket. This is a closed interval. Like this. Some other intervals are not strictly open and not strictly closed. So I'll give you an example of each one. So strictly open is from A to B. strictly closed is from A to B like this. Other intervals, we can have from A to B like this, from A to B like this. Or you can have it from infinity. So from A to infinity, from negative infinity to A, from A to infinity, half strict, or from negative infinity to A, half strict. And these are, this is open. This is closed. These are other. And I didn't really write this down, but these are infinity. These have to do with infinity, and it's pretty common to see these. Disjoint intervals, you'll commonly see this as we get into nonlinear inequalities. So for example, from negative infinity to -2. And then we talked about sets in the beginning of the review. You use a union symbol. They're disjoint because they're not connected. It's basically an OR inequality. So it's x is less than -2 or x is greater than 2. And then the last one, all real numbers. From negative infinity to infinity. There's also another type of disjoint, other interval, and it's using, the between inequality, as we saw in the review, it's between A and B. That's basically everything except for the disjoint interval. And this is what you'll most commonly see. Linear inequalities are almost always infinity inequalities, some form or the other. But then you'll see between a lot, and you might see disjoint. All real numbers is pretty rare. Now, the break-even point is an application of an inequality. So it's when the revenue is equal to the cost. So for example, if it costs me $20 to make a car, well, I'm talking about toy cars because it costs way more than $20 to make a real car. And I make $5,000 cars. Well, it cost me to $5,000 to make 250 cars. And I sell cars for $100 each. This is extremely exaggerated. How many cars do I need to sell to get to the break-even point? And if you notice, you only need to sell 50 cars out of the 250 cars you made. That's overpricing your cars. Three-part inequalities, like I said, is when one value is between the other. So it uses the extension of properties. So instead of this, what if we had something like 2 is less than 3x plus 5, which is less than 9? Well, we have to isolate the variable in the middle right now. So first we subtract 5, we get -3 is less than 3, which is less than 4. Sorry, 3x, which is less than 4. And then we get, divide by 3, we get -1 is less than x, which is less than 4/3. And this would be our final answer, or we can write it as from -1 to 4/3 using interval notation. If this doesn't work, as in most cases that are like 2x is -2x is less than 3x plus 5, which is less than 6x minus 3. There's x's everywhere. Then you split into two different inequalities. First, you solve -2x is less than 3x plus 5. And then you solve 3x plus 5 is less than 6x minus 3. To To solve a quadratic inequality, you solve the quadratic equation and identify the intervals determined by solutions of equation. So that's a lot to process. I'll give you a quick example. If we have x squared plus 5x plus 4 is greater than 0, you can either factor, you can use the quadratic equation, you can complete the square, but you'll find out that x plus 4 times x plus 1 is greater than 0. So if you want, you can draw a little number line. The solutions are -4 and -1. So these are the intervals that we have. And we want to know which of these intervals is the solution set. So we have to plug in values from each interval to see if it's greater than 0. So for example, in the middle interval, if you plug in 0, if you plug in -2, which is between this and this, you'll get -2 for this. You'll get +2 for this, and you'll get -1 for this. You'll get -2. So this interval doesn't work. If you plug in 0, which is on this side, you'll get 4 for this, 1 for this, which is positive, so this works. And if you plug in -5, which is on the other side, you'll get -1 for this and -4 for this. The product is 4, which positive, which works. So the solution would be from -infinity to -4 union -1 to infinity. Or you can write it in inequality form. X is less than -4 or x is greater than -1. This method can actually be used for any polynomial inequality if you can find the factors. And we'll tell you how to find the roots in our polynomial video, which should be lesson 5. A rational inequality has one or more rational expressions. It's basically a rational equation, but has an inequality sign. The values that make the numerator or denominator equal to 0 determine the intervals. And they're still, if they make the denominator equal to 0, then they're restricted. So an example for this, x plus 3 over x minus 5 times 2x plus 1 is greater than 0. Well, you use the same interval notation I did, and you test the values, find out which ones make it greater than 0, and that's your solution. If it's a strict inequality, like the one I just showed you, then the zeros aren't included. But if it's non-strict, then the zeros of the denominator aren't included, but the zeros of the numerator are. So I know it's hard to see over here because the text is covering it, but the 0 of the numerator is x equal to -3. This is included if it's a non-strict inequality. So basically, if it's a greater than or equal to. The zeros of the denominator, x equal to 5 and x equal to -12. These aren't included because they make the denominator 0. Final topic is absolute value equations and inequalities. So some more properties of absolute value. If we're given that a real number k is greater than 0, then absolute value of x equal to k, either x equal to k or x equal to -k. So for example, if we have absolute value of x is equal to 2, then x equal to 2 or x is equal to -2, because either one, if you plug it in here, works. If it's less than k, then you get a 3-part inequality. It's between x is between -k and k. While if it's greater than k, it's either x is greater than k or x is less than -k. So this one's slightly more complicated, but the easiest one of them all is if two absolute values are equal to each other, either the values are equal to each other or they're opposites. So we have absolute value of x is equal to absolute value of y. Either x is equal to y or x is equal to negative y. You can also say that negative x is equal to y, but this just comes here. And you can say that negative x is equal to negative y, but this is the same thing as this. Absolute value equations or inequalities require two cases as shown above, because these are either three-part or they're disjoint. They have an or in them. So an example of an absolute value equation, inequalities are sort of the same thing, but they're both of them require intervals. So for example, x minus 2, absolute value of x minus 2 is equal to 3x. So if this is the first property, x minus 2 is equal to 3x, or x minus 2 is equal to negative 3x. In this case, 2x is equal to negative 2, x is equal to negative 1. In this case, 4x is equal to 2, x is equal to 1/2. So these are the two solutions. You might want to plug them in and check if needed. Some special cases, if k is equal to 0, and the absolute value of k is absolute value of x equal to k, then x is equal to 0. This is obvious if you think about it conceptually, because an absolute value of, if an absolute value of something is equal to 0, that means the distance of it from 0 is 0. So it's basically 0. If absolute value of x is less than 0, then no solutions. If it's greater than 0, then it's basically all real numbers except x is not equal to 0. If x is less than 0, if k is less than 0, and absolute value of x is k, or absolute value of x is less than k, either way, that means the absolute value of x would be negative, so no solutions. If it's greater than k, then it's all real numbers. You don't even have to restrict that it's not equal to 0. That's it for our third video of Algebra 2 and Precalculus. I'll be seeing you next lesson, which would most likely be next week. Bye.